Hello, I welcome you all to this another interesting screencast. The problem reads, determine the magnitude and direction of the resultant force. This problem is coming from the Engineering Mechanics Statics textbook, 13th edition by R.C. Hibbeler. So the direction will be measured counter clockwise from the positive x-axis. Okay, great. So first things first, of course you can solve this using the parallelogram, or we can go with this other method where we resolve it just into components. So let's draw the components for each one. First and foremost, let's assign these forces. Let's call this F1, let's call this F2, let's call this F3. Right. F1 is just in the x-axis, so the y component of F1 is 0. Let's go to F2. F2 will have this component. It will have this component, then it will also have this component. Alright. F3 it will have this component. It will also have this component. Let's label them. This one is F2. This one is F2. This is F2 cos 30, and this is F2 sine 30. This is F3 times the rise, which is 3 divided by 5. This is F3 times the run divided by 5. Alright, let's label them. Let's fit them in our figure. So we have F there, we have the x component, the units are newtons. We have the y components, the units are newtons. So we have F1, F2, F3, and the summation of forces. Alright, so what is F1, the x component? It is 300. As a y component, it is 0. F2, what is the x component? It is 400 cos 30. What is the y component of F2? It is 400 sine 30. What is F3? The x component is negative 250 times 4 divided by 5. And what is the y component of F3? It is 250 positive by 3, the rise divided by 5. Summation, let's sum them up. So we're adding all these components so that we have the summation down there. So we have 300 plus 400 cos 30 minus 250 times 4 divided by 5. So I'll maintain 4 decimal places to just maintain my accuracy. So 4102. 300, I check it again, plus 400 cos 30 minus 250 by 4 divided by 5, 446.4102. The other one, we have 400 sine 30 plus 250 by 3 over 5. So this we get a 350. Okay, let's add it again. All right. So we have we have FRX is equal to 446.4102 newtons, and we have FRY equal to 350 newtons. And we want to find the resultant. So the resultant, if we are to draw this looks like this. If we are to draw this, it looks something like this. Okay. And then we have the resultant to be closer to the bigger force, which is Fx. Not so close, but something like this. Okay, so this is the resultant, which is FR. And then the others, Fx, this is Fy 350. Okay, this is 350. Alright, let me write it as this is Fry, which is equal to 350 newtons, and this is FRX, which is equal to 446.4102 newtons, right? Right. The resultant, just using Pythagoras theorem, is equal to square root of FRX squared plus FRY squared. Right. FR resultant is just going to be equal to 446.4102 squared plus 350 squared, and square root of that we have a 567.26 newtons. Right, theta is just going to be equal to tan inverse of FRY divided by FRX. Okay, and this is our angle here, okay, which is just theta. So therefore theta is just going to be equal to FRY is 350, FRY divided by 446.4102. Tan inverse of that, we have a 38.1. Okay, I think we are done. We have the resultant. This is the magnitude of the resultant force, and we have also the direction measured clockwise with reference to the positive x-axis. I hope the video was helpful, and if it was, give me a thumbs up, like my video, continue subscribing and liking my channel. Bye bye, and see you in my next screencast.